Welcome to Rges Algebra 1, Lesson 20A. We're going to be discussing Section 7.10, which are word problems, and 9.3, which are exponents. So I'm going to go to 9.3 first, and the several things I want you to, kind of the rules with exponents that you should know is x to the 0 equals 1. Now, one of the ways we can think about that, well, first off, x to the 1 also equals x. So if x squared equals x times x, so we're multiplying the x twice, okay, in all, okay, then that would be, if x to the 1 would be just having one x present. X to the 0 is 1. Now, one of the ways we can think about that is we recall, let's say, if we have x to the 5th over x squared, we're going to subtract exponents, and which would give me x to the 3rd. The reason we subtract exponents is x to the 5th is x times x times x times x times x. And x squared is x times x. And so when I cancel, I'm left with 3 up top. Okay, so that's kind of the visual form there. And we understand that that means subtract exponents. Okay. And so my answer is going to be this. Now, so what if I had x to the 3rd over x to the 3rd? Well, if I subtract exponents there, I'm going to get x to the 0. 3 minus 3. But anything over itself, like 5 over 5 is 1, x to the 3rd over x to the 3rd is 1. So that's why, see, we're building up a system of consistency, and that's why x to the 0 equals 1. So hopefully that's clear to you. Now my basic rules are going to be if I have x to the a times x to the b, what do I do? When I'm multiplying, I'm going to add exponents. So the basic rule would be a plus b. To show you an example, I would say y to the 3rd times y to the 5th, and all what together I have how many y's? If I drew that out, I would have y times 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 y. I'm adding my exponents. And so this is the example. This is the rule. My next rule would be if I have x, y to the a power, that will be equal to x to the a times y to the a. So there's my next rule. An illustration of that would be, let's say I have x, y to the 3rd power. All right, so I have x times y, that would be the first, times x times y, the second time, times x times y, the 3rd time. Well, how many x's do I have there? 3. And how many y's do I have there? 3. And so this is the example of why that's so. And finally, the 3rd example here would be x to the a to the b power, and that would be the same as x to the a times b power. What would an example of that look like? Let's say I had x squared to the 3rd power. That would be x squared times x squared times x squared 3 times. X squared would be x times x. X squared would be x times x. X squared would be x times x. And all together I have, we'll go way back up to here, I guess, 6x's. So that is the same as 2 times 3. Okay. Let's do one more like that. If I had x to the 3, I'm not going to draw this, to the 5th power, that would be altogether, by the same logic I just showed you in the last example, x to the 15th. So again, this is my rule, and this is my example 1, example 2. So let's run through several examples. This is x to the 8th times x to the 20th. I would have to add these, getting x to the 28th. Next example, 5 times r to the 7th times 6r squared. I'm going to multiply my numerical coefficients. 5 times 6 is 30. I'm going to add my exponents, and 7 plus 2 more is r to the 9th. The next example, 5x y to the 7th, cube it. And this is a little more challenging when we're thinking about it this way. You don't have to write this step, but we're thinking about it. 5 cubed times x cubed times y to the 7 cubed. Okay? Like that. So you have to deal with that 5 and cube it. 5 times 5 is 25 times 5 is 125. I can't simplify x cubed here, so that'll just go down, but I can simplify that by multiplying, remember? So go back to your rules if you don't. And this becomes y to the 21, or 21st. Next idea. Three x to the 5th plus 9x to the 5th. Okay, I'm so glad they gave a problem like this, because when students start working with exponents and they start multiplying and adding them, they get confused now with this. This is not variables being multiplied together or just with exponents. What this is like terms. Recall that? So when we're adding and subtracting, we're just worried about combining like terms. We do not change exponents. So be very careful with that. That's kind of a trick. Some of you that would have been very obvious, and others would get immediately confused. So this is just 3 of something. It happens to be the something is an x to the 5th value, plus 9 more of an x to the 5th value. So all together we have 12x to the 5th. Notice my exponent does not change. Okay. And then let's look at another one here. And don't get confused again. We are adding and subtracting here. When adding and subtracting, all you can do is combine like terms. Do I have like terms? Is x to the 3rd a like term with x to the 9th? No. No. So when you're adding or subtracting, all you can do is combine like terms. So there's no way to combine. So I cannot simplify this. My answer is the same as the thing I started with. Now let me take a look and see if there's anything else I want to help you with. Yes, I think it would be very worthwhile to do these oral exercises together. So if you will take your book and turn to page 378, put it on pause until you do. We're looking at page 378 in your text, and we're going to run through the oral exercises together, A through P. So come back when you're ready. And now let's look at them. I want you to look at them with me and get the answer in your mind for each one, and then ready for mine. A, we're going to add exponents. It'll be a to the fifth. I'm sorry, x to the fifth. X to the fifth. B, we're going to multiply. I'm going to go ahead and write them down. We're going to multiply exponents. It will be x to the sixth. C, think before you listen to mine. We'll add exponents. It will be x to the ninth. D, we'll multiply exponents. It will be x to the 20th. E, we'll multiply exponents. I'm thinking 5, and then 5 more, and then 5 more, and then 5 more, right? That's multiplication. Okay, so x to the 20th. F, I'm going to distribute over each variable, x cubed, y cubed. G, I'm going to distribute over each variable, a to the 7th, b to the 7th. H, I'm going to distribute, I'm going to distribute, that's a good way to look at it, over the constant and the variable. So I'll have 3 squared, x squared, but I'll need to simplify the 3 squared. So for when I'm looking at numbers, I'll go ahead and simplify that. 3 times 3 is 9x squared. I, again, I'll say 2 cubed. 2 cubed is 8x cubed. J, I'm going to have to multiply. X squared times 3 would be x to the 6th, and then y cubed. K, I'm going to multiply. I'll get x cubed, y to the 6th. L, you're going to multiply. X will be 8 to the 8th power, and y will be to the 12th power. M, I'm just going to multiply x cubed, so I've got 3 x's multiplied by 1 more. That will be x to the 4th. N, careful, like terms. I've got 2x cubed. O, no like terms, cannot simplify. I'll put simplify with a little circle around it and the idea that I cannot do it. And P, like terms, 4 minus 1 is 3x to the 5th. Now, if those aren't very simple for you, you want to go through 1 or 2 more times until you make sure that that is very clear to you before you start expanding it with a little more complication down in the exercises. And that's all we have to say about this. Now let's look. Actually, I think what I'm going to do is I think I'll do a key to those word problems on paper. That will probably be easier than taping them all. So I will bring that to class on Wednesday. So this will be the end of the tape, just focusing on 9.3.